Today you will see a demo of a provable chat that works as a layer 1.5 blockchain. This is part of our provable democracy tech. In the previous video, I presented what layer 1.5 is. It is an intermediary layer between L1 and L2. It uses the communication protocol from layer 1 but stores state off-chain, hence layer 1.5. Any decentralized blockchain needs a decentralized chat for all its users, and this chat is a smart contract in WebAssembly that uses the core protocol messaging system. Each chat client stores its own blockchain where each block contains a chat message as a signed transaction. So each message can be proven, and an entire excerpt of a conversation can be proven in its integrity. And now the demo. We have a local Mythos chain here that runs our WasmX protocol, which essentially is a WebAssembly engine that also re-implements the Cosmos SDK as smart contracts. Each node, node 0 and node 1, is also a chat client, and I will tell them both to join room 101. I'm telling node 0 to join room 101, and I have some logs here, so what happens is clearer. And now I'm telling node 1 to join the same room, and I will send some messages from each of them. So I have a hello from node 0, and a hello from node 1. And let's send another message from node 0. And here I have a web application that is connected through Kepler, through the Kepler wallet to one of the nodes. I'm refreshing this, and now I can see that there is a room, a new room, room 101. And if I click this, I can see all of the 3 messages that were sent by the 2 nodes. You may remember this application from a previous demo, and you know that we can also send messages from our wallet address. And each message is a signed transaction. And our transaction, our message, has been registered on the L1.5 blockchain. Now this chat data is off-chain, and it is private to each node that is connected to room 101. And the chat data itself is a chain of blocks. So here we can export any range of blocks. So we can form a proof of conversation. So let's say from block 1 to block 2, for example, and it will get us the first 2 blocks. And this data can be then verified by an on-chain verifier contract. So let's click on this button, and this will open the verifier interface. And here we can already see that the verifier contract has been called and our block data is a valid conversation. So what this means is these 2 blocks are valid. So each block contains the header and the actual data that is contained by the block. And the header contains the height of the block, a timestamp, the hash of its parent, its previous block, and the hash of the current data that we can see here. The data itself is a signed transaction that contains the chat message, And this is a normal Cosmos SDK transaction with a body, with the auth account information, and with the signatures. The body contains the messages that were sent, and in this case it is a message execute contract from our WasmX engine, and I have decoded the value here. It is a message sent to the chat contract, and the actual message is a chat command, a call to the send message method from the chat contract with the room ID and the message that was sent from the nodes. And the second block here should have the second message, hello from node 1. And of course, if we change the data here from 5 to 4, we should see an error, for example, an invalid data hash. Provable conversations are conversations that can become public at any point in time, and they are part of our digital democracy tech. The next step for provable conversations is the integration of our identity technology, and this will be presented in future videos.